In this part of the lesson, I'm going to talk about products involving polynomials with more than one variable. I'm going to start by multiplying polynomials by monomials. Then I'm going to look at FOIL again. I'm going to look at special products again. And finally, I'm going to look at some products involving polynomials with more than two terms. So let's start by multiplying polynomials by monomials. First, let's multiply the monomial 3x squared y cubed by the monomial 2x to the fourth y squared. So I'm going to need to multiply the coefficients together and figure out how many factors of x and how many factors of y I have. For this first example, I'm going to write out the step that shows that I'm multiplying the coefficients 3 and 2 together, x squared and x to the fourth together, and y cubed and y squared together. 3 times 2 gives me 6 for the coefficient. X squared times x to the fourth gives me a total of 6 factors of x. Y cubed times y squared gives me a total of 5 factors of y. So our product is 6x to the sixth, y to the fifth. Now let's multiply these two monomials. I have 2a squared b c cubed. And I'm going to multiply by 5, a, b to the fifth, c. This time I'm going to do the multiplication in my head. Looking at the coefficients, 2 and 5, I know 2 times 5 is 10, so the coefficient of the product is 10. A squared times a tells me I have 3 factors of a altogether. B times b to the fifth tells me I have 6 factors of b altogether. C cubed times c tells me I have 4 factors of c altogether. So the product is 10a cubed b to the sixth c to the fourth. Here we have a monomial 5x times the binomial x plus 2y. Since I have addition going on here, I need to remember to distribute the 5x to both terms in the binomial. So I'm going to multiply 5x by x, plus I'm going to multiply 5x by 2y. You did lots with the distributive property in Math 60, so you may be able to do this step in your head. That's fine. 5x times x simplifies to 5x squared. 5x times 2y simplifies to 10xy. Let's look at another monomial times a binomial, and this time I'm going to do the multiplication in my head. 6x squared times x plus 2y. Again, I need to distribute. I'm going to distribute the negative 6x squared to the x and the 2y. Negative 6x squared times x is negative 6x cubed. I have 3 factors of x. Negative 6x squared times positive 2y gives me negative 12x squared y. Wow, let's look at this product. Here I have a monomial 2x to the fourth y cubed times a polynomial with 1, 2, 3, 4 terms. I need to remember to distribute 2x to the fourth y cubed to all 4 terms in parentheses. X cubed minus 5x squared y plus 6xz squared minus y cubed. Since there are so many terms, I'm going to write out this step to make sure I actually distribute to all 4 terms. I need to multiply 2x to the fourth y cubed by x cubed. Then I need to multiply 2x to the fourth y cubed by negative 5x squared y. Then I need to multiply 2x to the fourth y cubed by 6xz squared. Finally, I have one more term. I need to multiply 2x to the fourth y cubed by negative y cubed. So let's multiply and see what we get. When I multiply 2x to the fourth y cubed by x cubed, my coefficient is still 2. X to the fourth times x cubed is x to the 7th. I have 7 factors of x altogether. And I have y cubed. For the second term, I'm multiplying 2x to the 4th y cubed by negative 5x squared y. 2 times negative 5 gives me a coefficient of the second term of negative 10. X to the 4th times x squared gives me 6 factors of x. Y cubed times y gives me 4 factors of y. Moving on to the third term, 2x to the 4th y cubed times 6x z squared. 2 times 6 gives me 12 as a coefficient. X to the 4th times x gives me 5 factors of x. Then I have y cubed z squared. For my last term, I'm multiplying 2x to the 4th y cubed by negative y cubed. So my coefficient is going to be negative 2, and I have x to the 4th, y cubed times y cubed gives me 6 factors of y. So now I want to revisit FOIL. Remember, we can use FOIL when we're multiplying a binomial times a binomial. Here we have the binomial x plus 5y times the binomial x plus 2y. So when I apply FOIL, the f reminds me to multiply the first terms together. So my first term comes from x times x. The O reminds me to take the product of the outer terms. X and 2y are the outer terms, so I'm multiplying x by 2y. I reminds me to take the product of the inner terms. 5y times x will give me my product of my inner terms. And finally, the L reminds me to take the product of the last terms. And that is 5y times 2y. So x times x is x squared. X times 2y, writing my coefficient in front, is 2xy. 5y times x, I can write as 5yx, but I'm going to write this in alphabetical order. Writing the variables in a term in alphabetical order helps you to identify like terms. So 5yx, I'm going to write as 5xy with my variables in alphabetical order. For my last terms, their product is 5y times 2y, so a coefficient of 10, 5 times 2, y times y is y squared. Now we can see that our outer and inner term products are like terms. 2xy and 5xy are like terms. Combining like terms, I have x squared plus 7, which comes from the 5 plus 2, xy, plus 10y squared. And now my product is simplified. Let's expand and simplify 2x minus 5y times x plus 3y. Again, we have a binomial times a binomial, so we can use FOIL. I'm going to go ahead and try to do the multiplication in my head. Multiplying the first two terms together, 2x times x would give me 2x squared. Now for the product of my outer terms, I'm looking at 2x and 3y. When I multiply 2x and 3y together, I get 6 for a coefficient, and my variables are x, y in alphabetical order. For the product of my inner terms, I'm multiplying negative 5y and x. Negative 5y times x, well, I'm going to have a coefficient of negative 5, and changing the order so that the variables are in alphabetical order, I'm going to write xy rather than yx. Now for my last terms, I need to multiply negative 5y and positive 3y. Negative 5 times positive 3 is negative 15. So the coefficient is going to be negative 15. Y times y is y squared. Now I need to look for like terms. 6xy and negative 5xy are like terms, so I can combine those. So I have 2x squared plus 6xy minus 5xy is 1xy. In simplified form, we don't write the 1, we just write xy, minus 15y squared. Well, let's look at the two expressions we just worked with. We multiplied 2x minus 5y, that binomial, by the binomial x plus 3y, and we got 2x squared plus xy minus 15y squared. Let's evaluate both of these expressions when x is equal to 4 and y is equal to 1, and see if we get the same result. FOIL tells us that we should, but let's actually verify this. So if x equals 4 and y equals -1, then, starting with our product of the two binomials, 2x minus 5y times x plus 3y would be 2 times 4 minus 5 times -1 times the quantity 4 plus 3 times -1. Simplifying, we have in the first set of parentheses, 2 times 4 is 8, minus 5 times -1 is plus 5. In the second set of parentheses, 4, positive 3 times -1 is -3, so minus 3. So we have 13 in the first set of parentheses times 1 in the second set of parentheses, which is 13. Well, but what about the expression we got when we expanded and simplified? That was 2x squared plus xy minus 15y squared. Well, if x is 4 and y is -1, this becomes 2 times 4 squared plus 4 times -1 minus 15. Now we want to make sure that we're squaring y, and y is a negative number, -1, so I'm going to put the -1 in parentheses with the squared on the outside. When we find 2 times 4 squared, the order of operations tells me I need to apply the exponent before I multiply. So I'm going to take 2 and multiply it by 16, which is the square of 4. Plus 4 times -1 is the same as minus 4. Minus 15 times the square of -1. Again, we need to apply the exponent before we multiply. So this is minus 15 times the square of -1 is positive 1. So we have 32 minus 4 minus 15. 32 minus 4 is 28. 28 minus 15 is 13. And indeed, we did get the same result both times. Both cases we got 13. Now this doesn't prove that the binomial 2x minus 5y times the binomial x plus 3y indeed equals 2x squared plus xy minus 15y squared, but we have shown that it's true when x is equal to 4 and y is equal to -1. Now let's find this product. Again, I have two binomials. The first binomial is 3x plus y cubed, and the second binomial is x squared minus 6y. Since I'm multiplying two binomials together, I can use FOIL again. The product of the first terms is 3x times x squared, which is 3x cubed. I have 3 factors of x altogether. The product of the outer terms, 3x and -6y, is -18xy, writing my variables in alphabetical order. The product of the inner terms, y cubed and x squared, is x squared y cubed, again writing my variables in alphabetical order. Finally, the product of the last terms, y cubed and -6y, would be -6. Y cubed times y is y to the 4th. Now I need to look for like terms. 3x cubed doesn't have a like term. -18xy doesn't have a like term. X squared y cubed doesn't have a like term. And likewise, -6y to the 4th doesn't have a like term. There's no like terms to combine, so there's nothing to simplify here. So now let's go back and look at our special products involving polynomials, this time in more than one variable. Let's multiply 4y minus 5t to the 7th by its conjugate. Well, the first thing we need to do here is remember what a conjugate is. So I'm going to multiply 4y minus 5t to the 7th by almost the same thing, except I'm going to change that sign in the middle. I'm going to multiply this by 4y plus 5t to the 7th. 4y minus 5t to the 7th and 4y plus 5t to the 7th are called conjugates. Next, we need to remember our special products rule. A plus b times a minus b is a squared minus b squared. So in this case, a is 4y, so we need to square 4y. minus b squared. Well, b in this case is 5t to the 7th. So we need to square 5t to the 7th. When I square 4y squared, 4 squared is 16, and then y squared. Minus, when I square 5t to the 7th, 5 squared is 25. T to the 7th squared, that's a power to a power, we multiply exponents. So this is t to the 14th. Now let's expand and simplify 5x cubed plus 4y squared quantity squared. An important thing to remember here is the 2 does not distribute over the addition. Exponents never distribute over addition. Another thing to remember here is this is one of our special products. A plus b quantity squared equals a squared plus 2ab plus b squared. So in this case, a is 5x cubed. I need to square that. Plus 2ab would be 2 times 5x cubed times b is 4y squared, so times 4y squared. Plus b squared, so the square of 4y squared. 5x cubed squared is 25. X cubed squared, again that's a power to a power, I multiply exponents, so x to the 6th. For our second term, I'm multiplying 2 by 5 by 4 to get my coefficient. 2 times 5 times 4 is 40. And I have x cubed y squared. 4y squared squared, well 4 squared is 16, and y squared squared is y to the 4th. Again, I had a power to a power, so I multiplied the exponents. Now let's square 7t to the 5th minus 4v cubed. So that means I'm going to take the quantity 7t to the 5th minus 4v cubed and square it. This is another one of our special products. So what we need to recall here is that the quantity a minus b squared equals a squared minus 2ab plus b squared. A in this case is 7t to the 5th, so I need to square 7t to the 5th. Minus 2ab, that would be minus 2 times 7t to the 5th times b, which is 4v cubed, plus b squared. So that's plus the square of 4v cubed. 7 squared is 49. T to the 5th squared, multiplying exponents, gives me t to the 10th. Negative 2 times 7 times 4 is negative 56. So my second term has a coefficient of negative 56. And I have t to the 5th, v cubed. Plus 4 squared is 16. V cubed squared, multiplying the exponents, is v to the 6th. I'm going to end this lesson by talking about products involving polynomials with more than 2 terms. So let's say we want to find the product of the binomial 3a plus b and the trinomial a squared minus 6ab plus 2b squared. Now Steve talked about a vertical method for finding products of polynomials with more than 2 terms. I'm going to show you another method you can use, which uses a table. It's very similar to the vertical method. So what I'm doing in my table is putting one of the polynomials, or the terms of one of the polynomials, along the top row. So my trinomial had terms a squared, negative 6ab, and 2b squared. And then in the first column, I'm going to put the terms of the other polynomial. My first polynomial, which was a binomial, had terms 3a and b. This is going to work just like a multiplication table that you might have encountered in grade school. In this cell, we're going to take 3a and multiply it by a squared. In this cell, we're going to take 3a and multiply it by negative 6ab. In this cell, we're going to take 3a and multiply it by 2b squared. In fact, in this first empty row here, what we're doing is distributing 3a over that trinomial a squared minus 6ab plus 2b squared. In the second row, in the blank spaces, we're going to take the b from that binomial and distribute it again over the trinomial a squared minus 6ab plus 2b squared. So let's do that. 3a times a squared is 3a cubed. 3a times negative 6ab is negative 18a squared b. 3a times 2b squared is 6ab squared. Now moving down to our last row, b times a squared, writing my variables in alphabetical order, is a squared b. b times negative 6ab is negative 6ab squared. And finally, for that last cell, b times 2b squared is 2b cubed. So now I need to look for like terms to combine. So when I'm multiplying 3a plus b by the quantity a squared minus 6ab plus 2b squared, well, starting with my 3a cubed, looking through the table, that doesn't have any like terms. So I'm just going to write that down, 3a cubed. Working down this first column, a squared b, well, that does have a like term. Negative 18a squared b and a squared b are like terms, so I can combine these two. This gives me negative 17a squared b. So I've already taken care of the negative 18a squared b. Moving down this column, I have negative 6ab squared. Does that have any like terms? Well, yes, there's a 6ab squared up here. Negative 6ab squared and positive 6ab squared add to 0, so I don't need to write anything down there. And then all I'm left with is this 2b cubed in the last cell. So I'm adding 2b cubed here. Let's find another product with a table. This one I have a trinomial, 2a plus 3b minus 4c, multiplied by a polynomial with 4 terms, 3a squared minus 7ab plus 5bc minus 4b squared. I'm going to use this same technique using the table. So I've placed the 2a, 3b, and negative 4c from that trinomial in the first column, and then the 3a squared c minus 7ab, positive 5bc, and negative 4b squared along the top row. So when I multiply 2a by 3a squared c, I get 6a cubed c. When I multiply 2a by negative 7ab, I get negative 14a squared b. When I multiply 2a by 5bc, I get 10abc. When I multiply 2a by negative 4b squared, I get negative 8ab squared. Moving on to the next row, when I multiply 3b by 3a squared c, I get 9a squared bc. When I multiply 3b times negative 7ab, I get negative 21ab squared. When I multiply 3b by 5bc, I get 15b squared c. When I multiply 3b by negative 4b squared, I get negative 12b cubed. Moving on to the last row, when I multiply negative 4c by 3a squared c, I get negative 12a squared c squared. Multiplying negative 4c by negative 7ab, I get positive 28abc. Multiplying negative 4c by 5bc, I get negative 20bc squared. And finally, multiplying negative 4c by negative 4b squared, I get positive 16b squared c. That's a lot of terms. Let's see if we can find any like terms. So when I multiply 2a plus 3b minus 4c by the quantity 3a squared c minus 7ab plus 5bc minus 4b squared, what do I get? Starting with this first cell, 6a cubed c, I've got this 4th degree term, and I'm going to work down through the terms by degree. So I'm going to find all my 4th degree terms first. Does this have any like terms? Well, let's look through the table. There aren't any other terms that have a cubed c as the variables, so we'll just write this down. 9a squared bc, this is also a fourth degree term. Does this have any like terms? Well, let's look to the table again. There aren't any other terms that have a squared bc as the variables, so we'll write this down. Negative 12a squared c squared is another fourth degree term. Does it have any like terms? Looking through the table, I don't see any other a squared c squared terms, so I'll just write this down. Negative 14a squared b, this is a third degree term. Does this have any like terms? Looking through the table, I don't see any a squared b terms, so we'll write this down. Negative 21ab squared is another third degree term. Are there any other terms on the table with ab squared? This time there is, negative 8ab squared. When I add negative 21ab squared and negative 8ab squared, I get negative 29ab squared. What about 28abc? Does this have any like terms? Yes, there's a 10abc in the table. When I add 28abc and 10abc, I get 38abc. What about 15b squared c? Does this have any like terms? Looking through what's left of the table, it does, 16b squared c. When I add 15b squared c and 16b squared c, I get 31b squared c. What about negative 20bc squared? Well, the only term I haven't used yet is the negative 12b cubed. These aren't like terms, so I just need to write those down. Negative 20bc squared, and finally, negative 12b cubed. So when I simplify this product, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. The table helped me to organize my work here. Let's find one more product before we finish this lesson. Here I want to multiply the binomial x minus y by the trinomial 3x squared minus 7xy plus 4y squared. And I'm choosing this problem to end with just to remind you that you don't have to use these tables. What we need to remember here is I need to distribute the x in the binomial to all three terms in the trinomial. And I need to distribute the negative y in the binomial to all three terms in the trinomial. So let's write that step out. I'm going to multiply x by 3x squared minus 7xy plus 4y squared. And then minus y multiplied by 3x squared minus 7xy plus 4y squared. And now let's do this distributing in our head. X times 3x squared is 3x cubed. X times negative 7xy is negative 7x squared y. X times 4y squared, remembering to write our variables in alphabetical order, is 4xy squared. Negative y times 3x squared gives our next term a coefficient of negative 3, and writing the variables in alphabetical order, x squared y. Negative y times negative 7xy gives us a coefficient of positive 7. And we have an x, and y times y is y squared. Finally, negative y times 4y squared is negative 4y cubed. Now we need to look for like terms. 3x cubed doesn't have any like terms, so I'm just going to write that down. Negative 7x squared y is a like term with negative 3x squared y. When I combine those, I get negative 10x squared y. 4xy squared has this like term 7xy squared. When I add those, I get plus 11xy squared. And then my last term is negative 4y cubed. And we've simplified this without a table. This concludes Lesson 5.